A very important concept in 3D, which many people disregard, is that actually meshes are formed by triangles and not by squares or more than 4 vertices faces. That may seem like something very trivial, but trust me, if you don't know this, it may cause a lot of troubles later down your 3D modeling pipeline. I will make a simple explanation here and show you the most basic case, but actually later we will probably face this in a lot of different situations. So the most simple case is that in the end, no matter what shapes you use in order to build your 3D model, your computer will convert them into triangles. And that matters a lot because no matter how you move the vertices in a triangle, they will always conform to a single surface. But that's not the case when the points are more. I will show you a quite extreme example, but it is very possible to happen in real life. These two shapes here have the exact same vertices on the exact same places, but are triangulated differently. And sadly, you never know how your computer will triangulate your shape in a specific position. So just take a look at this difference of the shape here and the shape here. And if it is something important for you, that may ruin a 3D model. Another very important concept in 3D is the difference between soft and hard edges. In order to understand soft and hard edges, we need to know that each vertex has a thing which is so-called normal. The normal is a little arrow pointing outwards that actually helps with the shading of the model. As you can see on the model on the left, each vertex has just a single normal which points perpendicular to the shape, and that makes it seem as if it is soft shaded, even though you can clearly see there is a triangle shape here. On the right though, you can see how there are two little purple normals. That actually indicates that there are two separate normals. And internally what your computer does is that it counts each one of these vertices as 2. The only reason it does not show you 2 vertices is for convenience, because this is easier to manipulate. And furthermore, if let's say for example you have this shape and they're all sharp, you will clearly see how now you have 3. So it may seem like a minor thing, but it adds up quickly, and the more vertices you have, the slower your program will run. When working with 3D, very often just having geometry is not enough. You may want to add some additional details and colors, and for that reason we have something called texturing. Texturing is the process of applying a 2D image on top of a 3D object, in this case this simple cube. But in order to paint on the cube, you need to flatten it somehow in order to be able to put a 2D image. This thing is called UV unwrapping and texturing. So in order to unwrap your model, I have marked here with red, as you can see, these edges. And these edges serve in the same way as they would be if you want to make a, let's say, a cube out of paper. You first make it in the sheet, and after this you fold it into the 3D shape. This is exactly the same thing, just in the opposite direction. And by marking these so-called seams, I am marking where the cube is cut. And once I unwrap this thing, that's the result you get. This is a flat version of the cube. Each vertex corresponds to a vertex in the 3D model, but notice that when I select one vertex here, it automatically selects 2, even though here is just 1. For example, also this one, it shows me 2 vertices, even though this one is just 1. So that comes to indicate that in the same way as with hard edges, this one is internally splitting the vertex, and that's something good to keep in mind. You can, after you unwrapped your model, you can actually apply an image. In this case, I will just put this simple UV grid. And if you want, you can preview how it will look on the model. Same way as with a cube, you can unwrap more complicated shapes, as this donut shape here. But it is nearly impossible to make a perfect unwrap without cutting it hundreds and hundreds and hundreds of times. It will be something similar to the maps of the globe we have seen, how they are cut in tiny little pieces near the poles. So here, in order to avoid all this segmentation, you can actually merge this and have this perfect little grid. I will remove this just so you can see better. But that will introduce some stretching. So even though here this is a perfect square, here it is not so square. You can try to accommodate it by scaling the UVs to fit as closely as possible. But as you can see, this edge is shorter than this one, while here they maintain the same shape. That may be good in some cases and bad in some others. You need to strike a balance as good as possible to have a good representation on the 2D plane that will help you paint on top of it, and also not have too much stretch, so something that you paint here does not look way too stretched in the 3D model itself. In that case, the same grid model will look like this, and as you can see here, the squares are slightly smaller than here, which in this case I think is a fair trade for the convenience of having that nicely laid out square grid.